All right, guys, here goes part 2 of the review. I'm actually starting page 3. Area of a regular octagon, that means I need to be doing 1/2 times A times P. Well, they already gave me the apothem. That's pretty nice of them. Nice of me, I guess. That means I got to track down the perimeter. Well, there is a right triangle hiding inside of that octagon. It told me the apothem is 8. If I find this bottom piece, I'll be able to find the perimeter of that octagon, which means I'm doing a trig problem. As long as I can find that central angle. If it's an octagon, there's always twice the number of triangles inside of the number of sides. So if there's 8 sides, that means there's 16 of these triangles. I can find the central angle by taking 16 divided into 360, which is 22.5 degrees. So it's a tangent problem because I have opposite and adjacent. So I'm going to do the tangent. You guys can't see a dang thing I'm doing. That was a smooth move. Here you go. Catch up a little. Tangent of 22.5 degrees would equal the opposite side over the adjacent. If I put that over 1, I'm cross multiplying. X has to be whatever 8 times the tangent of 22.5 is. So grab my calculator, make sure I'm on the degree setting. I am. I'm doing 8 times the tangent of 22.5. Now that is just the bottom right here of that triangle. Well, I know if I double it, I get one side of the octagon multiplied by 8 because there's 8 sides to an octagon. That's my perimeter. So I'm even write down 53.02. But I'm not going to get rid of this unrounded value. I'm just going to take that answer times 8 and times 1/2. There's the area of my regular octagon, round to the nearest tenth. 212.1 to an area, so it's inches squared. These can be some difficult problems here. It's very important that you get a plan. So I think for this object here, I'm going to try and find the area of the triangle. I'm going to find the area of the square and then get rid of the other triangle. So for this triangle, the formula would be 1/2 times base times height. I know the base is 10 and the height is 12. Plus the area of the square. So 10 by 10 squared, so that's 10 squared. And I want to get rid of this triangle because I only want the shaded area. Well, that would be 1/2 times base, which is still 10, and the height, which is 8. My plan produced a custom-made formula, and I can go straight to calculator time on this and say 1/2 times 10 times 12 plus 10 squared minus 1/2 times 10 times 8. Get a lovely answer of 120 millimeters squared because we're going after area again. So here, I think I'm going to do 1/2 of a circle plus that rectangle. So area of a circle is pi r squared. Area of a rectangle is base times height. I really have 3 things to find. The radius of the circle and the base and the height of the rectangle. Well, the base and height of the rectangle are the easiest ones. Base is 28. Height is 18. And if the diameter of the circle is 18, that means my radius is 9. All this goes into the calculator. 0.5 times pi times 9 squared plus 28 times 18. Rounding to the tens, I got 631.2 centimeters squared. Here they've got a map of an irregularly shaped item. Each of these squares is a 1 by 1 yard. A clarifying chemical is added to the pond based on the area of the pond. I need an approximate area of the pond because the chemical costs 13.88 per square yard. Well, let's see what we got here. Let's go with that's pretty much a full one. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 for sure. Probably going to call this. So now I know I got 15. So I'll start putting ones together. This looks like about if we put these two and this together, maybe all of this makes another one. If I put these three and this one together, probably got another one. That's not too much, but if I put that guy with all this extra stuff up here, probably got another one. I'm getting about 18 square yards. So I got to just take that 18 times my price per square yard. So 18 times $13.88 gives me a true cost of $249.84. All right. We're supposed to draw and classify the polygon, find the perimeter and the area. So A is at -2, 1. B is at 5, 1. Hopefully you all can see that. C is at -2, -4. So I got A, B, C. I got those two measurements pretty easily, and then I use Pythagorean theorem to find the third one. So I got 5 units here, 7 units there, and little Pythagorean theorem. Square root of 74 is that third side. So we want to find the perimeter and the area. The area is going to be easier because that's 1/2 of the base times the height. So 35, half of that is 17.5 units squared is the area. Perimeter, I got to add those 3 up. So I'm going to have to round that. That'll be 5 plus 7 plus the square root of 74. 20.6 units, because that's a one-dimensional measurement. 2 pages left. They want me to do it again. Draw and classify. Oh, I didn't classify that. The classification of this was a right triangle. This has got 4 points, so there's going to be something beside that. We got -2, 3. These units are going by 2, so I got to be careful. 6, 3. 6, -3. -2, -3. So this, it's obviously got 4 right angles. This is a rectangle. Let's see if I can count the sides. I got 3 for those 2 sides, and 1, 2, 3. I got 4 for the top and bottom. That means the area is 4 times 3, which is 12 square units. The perimeter would be all those added up, which is 14. Oh, this is a no, this is a good problem. As part of a Parks and Beautification Committee, Kelly's designing a circular flower garden. She plans to divide the flower garden into sectors and plant different colored flowers in each sector. What is the area of the sector to the nearest? We need this area of the sector. The formula for that is, all right, well, how many degrees out of 360 do we want times the area of the whole circle? We want 70 degrees out of 360 times pi times 6 squared. They want us to round to the nearest foot. That means everything's going into the calculator. 70 divided by 360 times pi times 6 squared. Area to the nearest square foot. So that's going to be 22, and this is feet. Square feet. This time we're doing arc length. They want our answers in two different ways, in terms of pi and rounded to the nearest hundredth. So they're wanting arc CD, that's from here to here. I want 185 out of the 360 degrees times circumference, 2 times pi times 5. So if I did it in terms of pi, I would leave pi out of the game. 185 divided by 360 times 2 times 5. I left pi out of there. Let's see if we can get a good fraction. That's 185 pi over 36. Or I just take that, plug pi in there. Or to the nearest hundredth would be 16.14. Let's play the game again. 65 degrees out of 360 times 2 times pi times 3.2. So again, 65 divided by 360 times 2 times 3.2. See if I can get a fraction out of that. I can. 52 pi over 45, or plug pi in, and I get 3.63. These are arc lengths, so that should be centimeters, this should be feet. Here's my conversions that I just learned. Take 90 times pi over 180, and I get pi over 2. Oh, it seems that this one didn't come through. Doesn't look like I got to do that. 270, we did that one in class, is 3 pi over 2. And in class we talked about 2 pi being equal to 360 degrees. Last page. So here's a bit of a blast from the past, the scale factor. What do I have to find if I find two matching sides, what do I have to multiply 10 by to get, I have to multiply 10 by to get 15? Well, if I don't know, 10 times what would get me 15? 15 over 10 reduces to 3 over 2. There's my scale factor. This is a 3 to 2 ratio. The perimeter of ABC, if that's 14, the perimeter would be 28. Perimeter of the other one, that's 21, plus 21 is 42. The area of ABCD is 4 times 10, which is 40. The area of the other one is 90. Now this is the big question, which leads into what we talk about actually next unit. How does the scale factor of the sides compare to the scale factor of the area? We know the scale factor of the sides was 3 to 2. Now the question is, what do I have to multiply 40 by to get 90? That reduces to 9 over 4. So the comparison between the areas was 9 to 4. The relationship between these two numbers. If this is a over b, you might be able to see that this happens to just be a squared over b squared, which should make sense. Sides are a one-dimensional concept and areas are two-dimensional or a squared idea. I know I went fast there. Remember, you can always pause and rewind and rewatch. And if there's questions or you found an error in what I did, let me know. Love to talk to you about math. Hope you guys do well. Study for the test. We're almost at the end.